Okay, that's up. Alrighty. And we are in 4.4, the atmosphere in Canvas. Now that's quite a lengthy page, and it's got a lot of things I'm going to share in a minute, a lot of things to unpack on that page, and then I'm going to share the AP uh, textbook video that goes with that. But there's a lot of vocabulary with it. There's a lot of moving parts that go with that as well. Okay, 4.4. I'm just trying to get attendance done here. Okay, I did update the grade book, so the soils quiz is in. I think most of you have done your AP Classroom 1 through 3 already. So when we finish watching the videos today, then I'll let you check on point 4 in a little while. But and some of you might, I think some of you have already done point 4 as well. But I did assign 5, but 5, we'll worry about that one for next class, but it has been assigned for those of you who like to get ahead of things. Okay, so we are in, let me open mine. Okay, so they have bracketed 4.4 and 4.5 together as both being under the atmosphere title. So I just want to point some things out before we start watching the video. Okay, so again, there's a lot to unpack on this page. And I think at some point during your science career, you've probably done the layers of the atmosphere before. And so the important thing to remember about that is it's the layer of gases around the Earth. It's what keeps us warm. It was what makes the Earth unique to other planets in that most other planets don't have an atmosphere like we do. So thus they are cold planets. So it does maintain our temperature, which also brings us back to global warming conversation, because what we're doing with our atmosphere is we're making it thicker and thicker, and thus we're getting warmer and warmer. And then we have all these climate changes that are going on right now. Um, so, um, like I said, I'm just going to try to briefly run through this for a minute, and then we're going to watch the video. So what you need to know is what the important thing about atmosphere is to know its composition. So even though oxygen is important to us, it is not the most abundant gas. So you need to remember that nitrogen is the most abundant gas in the atmosphere. We breathe everything in, but we can only use the oxygen, so we exhale everything else back out, including the carbon dioxide that we make as part of our metabolic processes. Ooh. So make sure you read that. Now, this one, there are several layers to the atmosphere. This is kind of backwards. So this is starting from the outside, going closer to the Earth, the troposphere being the layer closest to the Earth. So you want to make sure that you go through and click on all of these little message boxes so that you get some background information on what the layers of the Earth are. Essential questions. Again, we're getting close to the end of the year. And we want to make sure that we are looking at what the essential knowledge is, because that tells you what you need to know for the AP exam. So make sure that you're always touching on these points here. All right. So that being said, I'm going to go ahead and share the video, and then I'm going to let you come back and read this page over and work on the AP classroom questions. All righty. So let's look at this first one.
Covering topic 4.4, which is the atmosphere. So we'll be focusing on the temperature changes that happen in each layer of the atmosphere and how those changes actually define the layers. So our objective today is to be able to describe the structure and composition of Earth's atmosphere. In order to do that, we need to know what the major gases of Earth's atmosphere are, and we need to know their relative abundances, or what percentage of the atmosphere each one makes up. We also need to know that the layers of Earth's atmosphere are based on changing temperature gradients in each one, and we'll talk about why those changes occur at the end of the video. Our suggested science skill for today is to describe characteristics of an environmental concept that's represented visually. So before we talk about Earth's layers, we're going to run through the basic abundance or percentage that each of the gases in Earth's atmosphere represents. So first we have nitrogen at about 78%. Remember though that most of this is in the form of N2 gas, which really isn't reactive or usable for plants on Earth without being fixed by bacteria in the soil or by humans combusting fossil fuels to create synthetic nitrogen fertilizers. Then we have oxygen next at about 21%, and this is critical for life on Earth, of course, because animals, including humans, use it for respiration. This is a key APES vocab term that we should know, so it's not enough on an FRQ in APES to say that we breathe oxygen. That's just the act of pulling into our lungs. We need to use the word respire or respiration. We need to know that oxygen for respiration is used to break down glucose to form ATP, which is our main energy source. The third most abundant gas in the atmosphere is actually an inert or non-reactive noble gas called argon, and it's about 0.93%. Then we have water vapor, which depending on the conditions and region can range anywhere from basically 0% all the way up to 4%. It's also important to know that water, even though it naturally occurs in the atmosphere, is actually considered a greenhouse gas, meaning that it traps the sun's energy in the atmosphere and warms the planet. Now, it's not a greenhouse gas that we really need to be concerned about. We don't need to take any actions to reduce water vapor in the atmosphere because, for one, we need water to cycle through the atmosphere so it can precipitate back down to Earth eventually. But also, it moves through the atmosphere quite quickly, so it doesn't persist there for months or years like the greenhouse gases that we're more concerned about. And the final gas we'll talk about today is carbon dioxide, or CO2. So you may be thinking, well, it's only 0.04% of the atmosphere, but it actually has a tremendous impact on the temperature because it traps the heat coming from the Earth's surface, heated by the sun's rays, and it increases the temperature of the atmosphere. That will increase the temperature on land and in the oceans. So we'll really talk all year about how increasing CO2 levels in the atmosphere impact ecosystems all over the world. So before we look,
I apologize, it's buffering very badly. Not to mention there are commercials.
So before we look at the temperature gradient that defines Earth's atmospheric layers. We're going to go through each layer and talk about some of the basic characteristics of them so we're familiar with them. So the troposphere is the layer closest to Earth's surface, and it's where all of Earth's weather takes place. It extends up to about 16 kilometers from Earth, and you can remember that the weather takes place here because the prefix tropo comes from the Greek phrase tropos, which means to change. And as we know, weather is always changing. It's also the densest layer by far because it's the closest to Earth, so the majority of the Earth's water vapor is going to be found in this layer of the atmosphere, along with many other gases. And while ozone is really beneficial in the stratosphere, where it forms a protective layer that blocks us from a lot of cancer-causing UV rays, when ozone forms down near Earth's surface in the troposphere, it's actually considered an air pollutant. Now that's because it contributes to the formation of smog. It damages the human respiratory tract, so it can irritate our esophagus, it can damage our lungs, and it can damage the stomata of plants. And these are little pores that the plants use in their leaves for taking in CO2 and releasing oxygen. So ozone in the troposphere can be really harmful to humans and plants. Then we have the stratosphere, and you can remember S for second, since it's the second layer of the atmosphere. The most notable thing about the stratosphere is the dense ozone layer that forms here, which I mentioned earlier, helps block UV radiation. So that's really beneficial for life on Earth. Then we have the mesosphere, and you can remember M for middle. And it's important to point out here that with each layer up we move in the atmosphere, the gas molecules get less and less dense as they're further from Earth, and there's also less mass from layers above them pushing them down. Then above the mesosphere, we have the thermosphere, and I like to remember that therm refers to heat, and this is the hottest layer. It also absorbs highly damaging X-rays and UV rays, which is vital for life on Earth since those rays could damage our tissues and even be deadly to some organisms. This layer also contains charged gas molecules that light up when struck by high-energy solar radiation. This produces a really neat effect called aurora borealis, or the northern lights. And finally, there's the exosphere. And you can remember that exo means outside, like the exoskeleton of an insect. So this is the outermost layer of the atmosphere, and it's really where the atmosphere merges with outer space. Now we'll take a look at the way that temperature changes within each layer. So it's important to point out that these layers are actually determined by the changes in temperature gradient. So we'll start at the lowest layer and work our way up. And I want you to keep an eye on the graph over to the left and on these red and blue arrows as we go, because they can remind you what's happening to temperature in each layer.
And that's important.
So we'll start at the very bottom of the troposphere, right at Earth's surface. And as we move higher up in the troposphere, away from Earth's surface, it gets colder because the Earth's surface is warmed by the sun. And as we're getting further away from it, there's less heat. So think about climbing up a really tall mountain. It's going to get colder as you get closer to the top. So if we look over at our graph to the left here, we'll see that in the troposphere, this bottom layer, as we move up or further from Earth's surface, our line for temperature is going over to the left, which is over towards colder temperatures. So we have a blue arrow here reminding us that as we go up in the troposphere, it's getting colder. Then we have the stratosphere, where it starts to get warmer. So temperature increases as we move up into the stratosphere because the ozone layer at the bottom of the stratosphere is blocking most of the UV rays, which are high energy rays from the sun. These rays, however, hit the top of the stratosphere and warm it up, kind of like the very top layer of a pool in summer or Lake Michigan getting warmed by the sun. So if we look at our graph over here, we can see that after this peak ozone layer, which blocks a lot of those high energy UV rays, the stratosphere is going to start to warm back up quite a bit as we get towards this top layer, which is being warmed just like a pool in the summer gets warmed by the sun's rays, by these UV rays that are striking the top of it and warming it up. So then we have a red arrow going back up to remind us that in the stratosphere, we're getting warmer as we move up. Then in the mesosphere, it starts to get colder again because the gas molecules in this layer are very spread out. So they just really can't absorb much of the sun's energy very effectively, and so they can't heat up very much. So if we look at the graph of the mesosphere, we'll see that as we are moving up, temperature drops back down, and we're going to actually reach a point called the mesopause, which is about the coldest temperature ever found on Earth. This is about -150 degrees Fahrenheit. Then we get to the thermosphere where we're getting closer and closer to the sun. And because this layer is absorbing some very high energy UV rays and X-rays, this is going to cause it to heat up dramatically, up to temperatures as high as 3,100 degrees Fahrenheit. So remember that each layer of Earth's atmosphere is characterized by a shift in temperature in the opposite direction. So just remember, if you start on Earth and climb up a mountain, it starts to get colder. And then with each layer above, that temperature gradient is going to change in the opposite direction. Our science practice for the day is describing characteristics of a concept visually. So I want you to try to identify one of the layers of Earth's atmosphere in the diagram here that has an inverse relationship between temperature and altitude, and then describe why that's the case. All right, everybody, thanks for tuning in today. Don't forget to like this video if it was helpful. Subscribe for future APES video updates.
All right, commercial. All right, so again, back on the Canvas page, just make sure that you go through all of those little notation buttons and look at that. All right, so I'm going to go ahead and show 4.5 now, and then let you look at the questions in the AP classroom. You could look at those videos as well, but I prefer the ones that they're doing here. Okay. There we go.
For the most comfortable, luxurious, eco-friendly, and affordable, handcrafted American-made mattresses on the
Everybody, it's Mr. Smeeds, and today we'll be talking about
I'll go full screen. Hold on one second.
topic 4.5, which is
Let me do it.
global wind patterns. So we'll be learning how the basic properties of air, as well as how the rotation of Earth, give us the wind patterns that we see on Earth, and how they're also responsible for the weather patterns that we see. Our objective for the day is to be able to explain environmental factors that result in atmospheric circulation. And in order to do that, we need to understand three basic factors. Those are the intensity of energy from the sun, properties of air, such as density, and the spinning of the Earth on its axis, which produces something known as the Coriolis effect. Our suggested science skill to practice today is explaining relationships between characteristics of environmental concepts or models that are presented visually. So as I mentioned, the first factor that determines atmospheric circulation is how air's density changes under different conditions. So the first property of air related to its density is that warm air is less dense than cold air, so it rises. If you've ever been in a house with an attic in the summer, the difference in temperature between the attic and the basement is a really great example of this property. We also need to understand that warm air holds less moisture than cold air. So think about how dry and cracked your skin gets in the winter versus summer. That's because cold winter air holds less moisture. Now, another factor we need to understand is that as warm air rises, it cools, and that causes it to expand. And because cold air can't hold as much moisture, the water vapor that's in warm rising air will condense into liquid, which forms precipitation in the atmosphere, and then eventually falls down to Earth as rain or snow or sleet. And finally, after air has risen, cooled, and expanded, it's spread out, and then eventually it sinks back down. And we'll see that happen here in the diagram at 30 degrees north and south. So these properties of air help us understand the diagram to the left here, which is called a Hadley cell. The Hadley cell is this cycle of air circulation between 0 degrees and 30 degrees, and it's largely responsible for our global wind patterns on Earth. So now that we have our basic properties of air down, which is the first factor influencing atmospheric circulation, now we're going to introduce the second factor, which is energy from the sun. So because sunlight is most direct at the equator, that's going to cause air here to warm and rise. So we can see that as step one in the diagram. As warm air rises, it cools and expands, and because cool air holds less moisture than warm air, the water vapor has to condense into rain. And so if we look at step 2 in the diagram, that's why we see such intense rain at the equator, because that warm rising air has its water vapor condense and then fall down to Earth as rain. In step 3, the air continues to rise, cool, and expand further. In step 4, this air is expanding and spreading out even further. And then in step 5, we have cool, dry air is sinking back down to Earth right around 30 degrees north and south. And as we can see in the diagram, this is going to explain why we see this predictable pattern of deserts forming all over the Earth around 30 degrees north and south. It's because the air that's descending back down to Earth here is incredibly dry, so we get deserts. However, we're not quite done understanding the Hadley cell. If we look at the diagram, we'll see that we have this arrow here that's going from 30 degrees back towards the equator. So why is air moving along Earth's surface from 30 degrees back to the equator? Well, we have high pressure at 30 degrees north and south. That's because we have this column of cool, dry air that's sinking back down to Earth, and when a column of air is pushing down on Earth, it gives us high pressure. Meanwhile, at the equator, we have low pressure, and that's because warm air being heated from the sun is rising at the equator. And we know that air moves from high to low pressure, so along Earth's surface, we'll see this air from 30 degrees flowing back towards the equator. That's because we're moving from high to low pressure. Another way to think about this, though, is we have to get back to step 1 of the cycle somehow, and so we need replacement air to come in and fill this vacuum or this gap of air left by the air that's rising at the beginning of the Hadley cell. So we've covered why air rises and expands at the equator, sinks back down at 30 degrees, and then moves along Earth's surface back towards the equator. But that's only 2 of the 3 factors that determine atmospheric circulation. The third factor is Earth's rotation. So believe it or not, if Earth were standing still rather than spinning, wind would move more or less just straight north and south. Because the Earth is rotating, though, that means that objects such as wind or this baseball we'll talk about here in a second that are traveling through Earth's atmosphere are actually deflected in the opposite direction of Earth's rotation. So another way to try to understand the Coriolis effect is to imagine that you're standing at the North Pole and you're throwing a baseball straight south. So you may be aiming the baseball along this line here, but because Earth's rotation is causing the ground beneath the baseball to spin, the baseball will actually be deflected the opposite direction of the spin. So even though the ball was traveling on this trajectory, it's going to end up here to the left of where you aimed it because the ground beneath the Earth is spinning. Now the same thing is true of the wind between 0 and 30 degrees. So because this air at 30 degrees is moving from a high pressure system back down to a low pressure system, it would flow directly south or directly north in the southern hemisphere. But because Earth is spinning this direction, the wind from 30 to 0 degrees is deflected the opposite direction. So what we get is wind moving from east to west between 30 and 0 degrees. Now, because 30 degrees is a higher pressure area than 60 degrees, wind is also moving from 30 degrees out to 60 degrees. The wind in this direction, though, is deflected in the opposite direction as between 30 and 0. And that's because the Earth at 30 degrees is spinning so much faster than it is at higher latitudes at 80 or even at 60, that the wind is actually going to be deflected in the same direction as Earth's spin. Now that's a confusing concept, so let's talk about this using the example of a treadmill. Imagine that you're running along a treadmill that's going 15 miles an hour, and suddenly you jump to a treadmill right next to you, moving in the same direction, but only moving 2 miles an hour. So it's moving far more slowly. You're going to have so much momentum coming from the 15 mile an hour treadmill that jumping onto the 2 mile an hour treadmill is going to cause you to run forward quite a bit. And so that's why we see wind from 30 degrees to 60 degrees actually traveling in the same direction as Earth's spin. It's because the Earth is spinning so much faster at 30 degrees than 60 degrees that the wind is deflected in that direction of Earth's spin. Now we'll put together all 3 factors, so the sun's energy, air properties like density, and the Coriolis effect, to take a look at how Earth's global wind patterns are the result of those factors. So the first thing I want to do here is point out that our Hadley cell here still works the same way. We're just looking at it from a side view where we see all of Earth, rather than looking at it from the viewpoint of being on Earth's surface like we did in our first slide. So if we look at the Hadley cell, we can remember that the sun's rays are striking the equator most directly. So that's heating the air here and causing it to rise. Then it sinks back down at 30 degrees. And because of this high pressure system at 30 degrees, air is going to be moving out towards 0 degrees and 60 degrees. We can see here that with our low pressure at the equator, our higher pressure at 30 degrees, and then our low pressure again out at 60, we're going to get air moving out from 30 degrees towards 60 and towards the equator. But remember that the air does not move in a straight line. It's deflected based on the direction of Earth's spin. And so between 0 and 30 degrees, we have our air moving from east to west, and we call those eastern trade winds because they used to drive trade from the east to the west because the ships were dependent on sails. This also drives the circulation of the ocean currents in a clockwise direction in the northern hemisphere and in a counterclockwise direction in the southern hemisphere. Then remember that between 30 and 60 degrees, the wind is blowing from west over to the east. And this is because the Earth at 30 degrees is moving so much faster than out at 60 degrees or 80 degrees that the wind is deflected in that same direction as the Earth spins. So it moves from west to east. Now this means that in North America, where we live, we get our weather from the west. So if you're looking at the radar to try to see if we're going to have a snow day, you're going to look over at Chicago and Wisconsin because you know that their storms are headed our direction because we have westerlies or western prevailing winds, which means our weather moves from the western United States over to the eastern United States. Our suggested science skill for Practice FRQ 4.5 today is explaining relationships between characteristics of environmental concepts or models that are represented visually. So I want you to see if you can explain how is the sun responsible for the pattern of air circulation that we see in cycle C on the diagram here. All right, everybody, thanks for tuning in today. Don't forget to like this video if it was helpful. Subscribe for future APES.
Okay. All right. So again, you need to come back to Canvas and make sure that you look at the visual maps. All right. So with atmosphere, he mentioned several different cycles. The important thing is that hot air rises and cool air sinks, and you need to just keep that in mind and know the terms Hadley cells and Coriolis effect and global trade winds. Let me get my page to change. All right. So like how he ended with that map, you need to be able to, okay, so these are the cells here, and this is the last one. So come back and look at this again, click on all of the little text box talking points, and this will help you with that question that he said is assigned to you in the AP classroom. So this is the filled in picture of that assignment that he just ended with, and so everything is labeled for you, and they will explain what all of the different types of trade winds are. Okay, so use this one to help you answer that question. All right, so I'm going to stop talking to give you a chance to go to the AP classroom and look at that assignment. So if you haven't done 4.4, you should do, most of you have done it, and then do 4.5. Okay, all right, Gabby, we need to, let me do attendance first, and then we'll see what I can do about getting those assigned to you. Journey and Jada, you need to also do the soil quiz. It deals with 4.3. So y'all have, those are the missing grades I have right now. For soil, the soil is a soil quiz, and really it's in unit 4. That's Jada and Journey. Okay. All right, so again, I'm going to do attendance, and then I'll be monitoring the AP classroom. Okay. So what did I do? All right, Gabby, can we do a pull-out room? Set up a breakout room. right, I am back. Anybody else feel like they need a breakout room moment? Okay, folks, I'm going to hang around for a little while, but if you have no questions for me and you're up to date, you are free to go. You have a great day. Stay warm.